I'm DevPoodle. Today I'll be showing you how to make procedurally generated planets in Godot. This is what the final result will look like. First, we'll procedurally generate the terrain using 3D noise. Then we'll add a layer of water around it. Finally, we'll create some custom materials for both the terrain and the water. So let's begin. Alright, first we need to create a new scene that we'll call Planet. It's going to be a Node 3D scene. Then we'll give it 2 children. Both are going to be mesh instances. So let's do this and then just copy and paste. And move that. I'll name the first one Terrain. And the second one Water. Let's add a script to the planet. Just call it Planet GD. That should be fine. To set up the script, let's first make it a tool. Then we'll define 3 export groups. Export group. I'm going to call the first one Sphere. Then let's just copy and paste it twice. And I'll rename the second one Terrain. Then the third one Water. These segment our export variables into different groups so that it's easier to navigate them in the node inspector. Then we'll define 2 variables for this script. First is going to be terrain. This is going to be an array mesh. And the second one is going to be water, which is also going to be an array mesh. Then let's create the ready function. First thing we're going to do is go to our terrain node and set its mesh equal to the terrain array mesh that we have created. And then we'll do the same thing for water. Water.mesh equals water. Finally, we'll call functions update terrain and update water. Let's then define these functions. So first, update terrain. This is going to take no inputs and give no outputs. Pass, and then copy and paste this. Water is going to be the exact same. Except let's replace this with water. So the first thing we want to do is generate a basic sphere for the terrain. So under export group sphere, let's export a couple variables. First is going to be radius, which I'll just set to 8 by default. We want to create a setter for this. So set new radius, and then radius equals, we ideally don't want the radius to be below 0, so let's do max f, let's say 1, and then radius. Oh, and this should be new radius. Finally, let's call update terrain and update water, because after we set the radius, we want both of these to be updated. All right, and then we're going to create another export variable for the sphere called detail, which I'm going to set to 64 by default. And then we'll create a setter for this as well. Detail equals max I, because detail is going to be an integer, 1, and then new detail. Then we just want to update terrain on this one, and we're not going to update water. So radius is of course going to be the radius of the terrain, and detail is essentially going to be how many vertices it has. I mean, it's not like a direct measure, but it's like how many times it's subdivided. So to actually get a sphere, we're going to create a new function called createSphere. It's going to take in a radius, a detail value, and it's going to return an array. So the first thing this function is going to do is create a new default sphere mesh that we'll just call sphere. Then it's going to set the sphere's radius and height. And height is just going to end up being the radius times 2. Then we'll use the detail to set the radial segments and rings. Detail times 2. Sphere dot rings equals sphere detail. Finally, we will return sphere dot get mesh arrays. So now we can just call this createSphere function, pass in a radius and detail value, and we'll get the arrays for a default Godot sphere. So before I actually change update terrain and update water, let's go up to here, and we're just going to create default array meshes. So just do array mesh dot new, and then we're going to do the same thing for water, because I have forgot to do this earlier. Okay, now we can go to the update terrain function and test if terrain exists. If it doesn't exist, then we just want to return early, because that means we're not finished initializing the node yet, and so we just want to not do anything. So then, assuming it does exist, we'll get the mesh arrays from the create sphere function. So mesh arrays equals create sphere, and then we're just going to pass in the radius and detail values we exported earlier. We'll get the terrain array mesh, and we will clear whatever surfaces currently exist, then add in the sphere surface we just created. So add surface from arrays. We're going to be using mesh.primitiveTriangles, and the arrays are just going to be the mesh arrays we just created. All right, let's save, then go into the 3D view. And at the moment, we don't see anything. What we're going to have to do is go up to scene, go down to reload save scene, and then press this. Now, if we zoom out, we get the default sphere. Basically, throughout this entire video, whenever we save the script and you want to see what the changes have made, always remember, go up to scene and click reload save scene after you saved your script. This will reload everything, and then you should see the updated results. So I'm going to be editing that out from later on in the video. Just remember, you always have to go reload save scene whenever you want to see the results of your updated script. All right, now I'm going to go up to perspective and go to wireframe. This allows you to see like the individual outlines of all the polygons in our mesh. So if we go up to sphere, so if we go up to radius and try to change it, it doesn't work. That's because we messed up our exports. So let's go to script, go up here, and I reversed these. So I actually need to set this to radius and then this to new radius. And it looks like I didn't make that mistake here. Okay, let's go back. Then try to change radius now. And it works. As you can see, smaller radius, smaller sphere, bigger radius, bigger sphere. So let's just reset that back to its default. Then for detail, that's going to be like how many polygons there are. So if we halve the amount of detail, as you can see, we get far fewer polygons. But if we, increase it, like let's say it's set to 256, then we get a lot of polygons. Like we have to zoom in to start seeing them. So I think the default value is going to be fine for this case. Especially while you're messing around with the planet, I recommend keeping it at a low detail, because the higher it is, the longer it's going to take to regenerate the sphere every time. So, all right, let's go back to the script. So we're going to be adding 3D noise to it, so that has, bumps and stuff that looks like mountains and valleys and that sort of stuff. So under the terrain export group that currently doesn't have anything, let's add some new variables. First, we're going to add noise. This is going to be a fast noise light.new. Then we'll add a setter for it. Noise equals new noise. Then we just want to see if noise actually exists. So if noise, then what we want to do is get noise.changed. This is a signal that will be emitted whenever any part of the noise is changed. So do noise.changed.connect. And then we want to connect this to update terrain. So basically, whenever the noise is changed, the terrain will update. Second thing we want to add is height. I will set this to 1 by default. Let's do set new height. So height equals max f 0 new height. Then we want to update terrain and update water. So this height is essentially going to represent the bumpiness. So the noise will give us what pattern, and then the height will essentially multiply the height by the noise, so that the higher the height, the more bumpy the terrain is. So we're going to have to find a new function called getNoise. This is going to take in a 3D vertex. And it's going to give us some noise value, which is going to be a float. So it will return noise.getNoise3D, and we'll use the 3dv function, so then we can just pass in vertex. We first want to normalize vertex, just in case it isn't normalized already. Then we are going to multiply by 2. So then after we get the noise, let's add 1 to this, then divide by 2. So what this does is it makes sure that the noise is from ranging from 0 to 1, which is what we want. Then finally we can just multiply by height, so that the higher height value is, the more noise is returned. So now that we have the getNoise function defined, we can actually add the noise to our vertices. So first we want to add an extra check to update terrain, or not noise, because if noise doesn't exist, then we don't want to update terrain either. So we can get the vertices from the mesh arrays, which is going to be a packed vector3 array, by doing mesh arrays, array mesh dot array vertex. So each component of the mesh arrays corresponds to an array that stores information about the mesh. The array mesh dot array vertex item is the vertex array. So then let's loop over all the vertices for I int in vertices.size. We will get the vertex at that specific index. Then we will add to this vertex vertex.normalized times the noise, so get noise, and then we can just pass in the vertex. Finally, we will update the vertices array. So this should all be working. Let's save and reload. All right, so I reloaded it. If we go into terrain now, we can see there's a default fast noise light. Let's open that up. And we should be getting some basic noise. I'm going to bump up the height value quickly just so we can test it out. So let's set it to 4. And as you can see, the sphere is expanding, but it's not necessarily the noise that we want. So what I'm going to do is quickly reset the noise, then create a new fast noise light. And then from here, once we change stuff, now the sphere should be updated. So let's increase frequency. And as you can see, we have basic terrain. Now you want to play with this noise a lot. There's a lot of options in fractal and domain warp and the type of noise you're using. But for now, I'm just going to use the default because that should be fine. All right, and then let's actually go back to normal mode real quick. All right, let's go back to the script. All right, the next thing we're going to do is generate the water. So let's scroll up, and we're going to add some variables under the water export group. First, we're going to export water level. This is actually going to be a range from 0 to 1. And by default, it'll just be set to 0. We'll also add a setter for this. Then we want to update water. The second export is going to be water detail. This is literally going to be the exact same as the sphere detail that we defined up here. So we'll set to 64 by default. Add a setter. Then update water. Now let's scroll down to our update water function, and we're going to add stuff to this. So first we're going to add a check to make sure that water exists. So if not water, then we want to return. We also want to check if water level is 0. So if water level equals 0, then we just want to set water to be invisible and then return. So if water exists and water level is not 0, then we want to set water to be visible. Then to get the radius of the water, we're going to store it in a new variable. We're going to use the lerp_f function. So we're going to lerp between radius and radius plus height. So if you think about it, radius is the minimum height of the terrain, like the lowest point in the terrain will be radius, and the highest point will be radius plus whatever the height is. So essentially we have this range that's going to be minimum height and maximum height, and we are going to use the water level variable we stored earlier to get where in between this we want the water. So basically if water level is 0, it would be at radius, which means you wouldn't see it at all. But if it's at radius plus height, then it's going to be taller than all of the terrain, or it's going to be like at the very max height of the terrain. Then we'll get mesh arrays in the same way we did in the update terrain function. Except for this one, we're going to be using the water radius and water detail. Then we can just copy and paste this essentially, except replace terrain with water. All right, now let's reload and save. And as you can see, water is invisible by default, but if we go to water export group and set water level to, let's say, 0.5, then you can see that a lot of it gets filled in. At the moment, the water is the exact same color as the terrain, so it's kind of difficult to see, but if we arrange through water level, hopefully that is a little more obvious as to, there being a separate sphere under there. So obviously we need to get terrain and water to have different materials, and we also just want to add materials in general. So let's go back into the script. And we are actually going to export the materials in the terrain and water groups. So first let's get the terrain material going. So export terrain material. We'll add a setter. Terrain material equals new terrain material. Then we want to see if terrain exists. So the way we're going to do that is by going if terrain dot get surface count. So essentially, if this is 0, what that means is that the terrain has no active surfaces, so like the terrain doesn't exist. But if it's more than 0, then this will be true, and then this is going to happen, where we're essentially just going to set the material of the first surface in terrain. So do terrain.surface set material. Then we're just going to do the first one, which is indexed at 0, then pass in the terrain material. Now let's copy and paste this for water. Then we essentially just need to rename everything. So let's call it water material. It's going to be new water material. And then we want to set the water's material. So place the terrains with water. Okay, so now we're exporting materials properly. Let's make sure they actually work by going to the update terrain and update water functions. So because we're clearing the surfaces in each of these, we actually have to re-add in the material at the end of the function. So let's actually go up top here, copy and paste this last line where we set the terrain's material and then just put it at the end here of update terrain. Then we're going to do the same thing for water. So just replace these. All right, now let's save and reload. So now in these exports, we have the terrain material and water material. So let's just set some defaults. We'll have the terrain material just be green for now. And we'll have the water just be a default blue. So now that we have the distinction, as you can see, it's far easier to see the difference between the terrain and the water, and you can much more easily tell that the terrain has a lot of bumpiness to it. So the rest of the video is going to be making actually good materials for the planets. We ideally want the terrain to have a gradient as it gets closer and closer to the water, and we also want the water to have a gradient so that deep parts of the water are darker than parts of the water that are more shallow. So let's replace the terrain material with a new shader material. Then a new shader. I'll just call it terrain.gd shader. Let's go into the shader editor and open up terrain. So I'll delete the light function. Then we'll add in render modes for this. So we just want the render mode world vertex chords. Then we have a bunch of variables we need to find. So we need to find 5 different uniforms. 4 of them are going to be floats and one's going to be a sampler 2D. So let's just do uniform float. The first is going to be specular, which I'll set to 0.8 by default. Then let's copy and paste this 3 times. The second one is going to be called roughness, and I'll set it to be 0.6 by default. The next one is going to be called radius. Now this is actually going to be set to whatever the radius of our planet is. So let's see, the radius is currently 8, so this is going to be 8. The final one is going to be height, and this is going to be set to the height of our planet, which is 4 currently. So let's set that to 4. Now what you'd actually want to do is go into the script and update these like automatically, so you can update the uniform of the material whenever the radius or height changes, but I'm going to skip over that for now. And finally, let's define a sampler 2D, which is going to be the gradient we're using across the terrain. And we want to do repeat disable. So the vertex shader is going to be fairly simple. First, let's define a varying called world vert, and it's going to be a vec4. What a varying is it's something that you set in the vertex shader and then you have access to in the fragment. So essentially you can pass stuff over from the vertex to the fragment. So in the vertex, we're just going to set world vert equal to the inverse of the model matrix times vec4, the default vertex, and then 1. The reason we're going through all of this is that when we move the planet around, the gradient doesn't change. It should stay the exact same no matter where the planet is. So next we're going to define the fragment shader, and this is also going to be fairly simple. We'll set specular equal to the uniform specular, roughness equal to the uniform roughness. Then we'll get a UV by doing float color UV. And to get this, let's do length of world vert.xyz minus radius, and then divide by height. This essentially is going to give us a 0 to 1 range, where 0 is the lowest point on the terrain and 1 is the highest point. Then we'll set the albedo to just be the texture of the gradient sampled at the color UV. So vec2 color UV, and then the y component is just going to be 0. Then do .rgb. All right, now I just have to set a basic gradient. So if we go into shader parameters, we can just create a new gradient here. First, let's reset height. I don't know why that's changed. Then we can set a new gradient. All right, go to gradient. Now we can change this. So let's just mess around with it a little bit. So as you can see, if we move black up here, now there's almost like a, black outline around the terrain, which could be something that you want. So I'm just going to fiddle with this until I get a gradient that I like. I'd recommend you do the same. I'll skip past that. All right, this is the gradient I ended up with. You can try to copy this if you want, or you can just, go with your own art style. The nice thing about this material is that you can just change it to be whatever you want. So next we're going to create a water shader, and this is going to be a little bit more complicated, but let's get rid of this default water material, replace it with a shader material, create a new shader. I'll just call it water.gd shader. Then open that up. So let's actually copy and paste all of these definitions. Specular, let's change the default to 0.9. Change the default roughness to 0.3. Radius should stay the same, except instead of height, we're going to do level. And this is not actually going to be the water level, this is going to be the radius of the water. So if we go into here, let's change water level to 0.5. So then because it's 0.5, it's going to be radius plus half of height. So in this case, that's going to be 10. Again, you probably want to calculate this in the script, but I'm just going to leave it as it is for now. Then gradient's going to be the same, but we're going to add in another uniform. It's also going to be a sampler 2D. This one's going to be the depth texture. So do int depth texture then repeat disable. This essentially gives us the depth at the screen at every pixel, which we're going to use to get a nicer gradient so that the deeper the terrain goes, the darker the water is above that point. So to get the depth, we're actually going to create a new function called getLinearDepth. It's going to take in a UV and a 4x4 matrix called inVProjection matrix. And we have to specify this to return a float. So first it's going to get the depth in the depth texture at the corresponding UV, and then .r. Then we're going to do some math to make it linear, because by default the Godot depth texture isn't like a linear value. Like if something's 1 meter away from the camera, it's not going to give us a 1 meter. I essentially just want to make it so that it's actually giving us the amount of distance from the camera, so we're going to do some math to get that. You don't have to worry too much about this like specific process of how we're getting it. You can just follow along with the coding I'm doing. I believe there's a part of the Godot docs that explains how this works, but if I remember, I'll put it in the description, or if I can find it. I don't remember if it's still there or not. So we only want the fragment function in this case. First thing we're going to do is set roughness to the roughness uniform, specular to the specular uniform, just like we did in the terrain shader. So we want to get the difference in depth between the surface of the water and the bottom of the terrain, like the terrain that's under the water. So let's call it depth difference. So it's going to be vertex.z minus getLinearDepth, and then the screen UV and the inverse projection matrix. Then we will use this depth difference to get a UV value. So float color UV, kind of like in the terrain. Then do depth difference over level minus radius. So then we'll just use this to get the albedo value of the gradient texture. Gradient vec2, basically the same thing as in the terrain, color UV 0.RGB. Okay, now we just need to specify the uniforms. Go to shader parameters, reset level, then set a new gradient. As you can see, it's already working. In this case, though, the deeper parts are white and the shallower parts are black. We kind of want the opposite. So if we just swap these around, that's closer to what we want. Now we just have to specify what these colors actually are. So let's go for like a light blue on this one, and a darker blue on this one. And then shift this a bit. As you can see, that's the final shader. You get this nice stuff where the terrain is deeper, the water is darker. So you can almost sort of see the terrain under the water. Alright then, that should be everything. Let's go back to the demo scene I showed at the start of the video. Everything I've made in this tutorial, including this demo scene, is linked in the description. There is a final way to improve the terrain that you might want to look into. For both the terrain and water, we used Godot's default sphere mesh. A far more optimal solution would be the box sphere. I showed how to generate these in my video on procedural meshes, so if you're looking to improve this script, that's the first place I'd recommend checking out. The example demo in the description actually has an option where you can change it to use a box sphere instead, so you could also copy and paste it from there if you want. Either way, I hope this tutorial helped you with whatever you were looking for. Thank you so much for watching. I hope you have a wonderful day, and I'll see you later. Goodbye.